because there seemed to be some interest in this issue of hybrid modeling and the issue of sort of this service delivery network, I did want to highlight, I put an extra model on the Google Drive site called Multi-Clinic ABM Process Hybrid NC. And the NC was from North Carolina last year. And this is one of the models we built up in this boot camp with folks there. So in our 5 or 6 day boot camp, the participants typically build a dozen to 20 models, something like that. And this is one of them that we built. If you download that and load it in, what you'll see is something like this. So here you'll see we have, does anyone recognize something different about this model compared to what we saw before? What's new about this model? Yeah. Good. That's right. It's like Da Vinci's measure of man. You have two populations. One is a population of people, and one a population of clinics. And this model is actually depicting a situation where we have two types of agents: people, clinics, and the people interact with the clinics. So people exhibit care-seeking behavior that brings them to the nearest clinic when they encounter health difficulties. This model is a teaching example. We built it up in class, and it has a very simple sort of structure. And we have care-seeking behavior, which brings people to come under care. And if you run this model, what you'll find is that we have people in the population. They're shown in green in the initial population. Sorry, here in red. And when they decide to seek care, they have this sort of border around them, and they'll actually go to the nearest clinic. So this care-seeking behavior will is contingent upon them needing to seek care. And when they go under care, they actually get the nearest clinic out of all clinics, and they go to that clinic. And these clinics here are shown in this color. They're just another type of agent, and they could be placed geographically based on GIS data. But the clinic representation basically keeps track of patients' flow through the clinics. And so what you'll see, for example, is information on resource utilization, what fraction of the time the clinicians at the clinic have been serving individuals coming to the clinic. There's some indication whether the treatment was successful or not. And in general, you can, when you treat people for a condition, you can get them to respond. If it was successful, you actually tell them, okay, you're cured of your ailment. Otherwise, they stay with their ailment. So you could imagine, this is, again, a toy example, but you can imagine that in this case, we have a much more extensive representation of perhaps filing associated with cases. And these clinics could be service centers that deal with disability services or services for those with mental health or what have you. And you have a population that seeks out those services. And you could place these clinics according to their actual geographic location and have people attend to them based on their location. So these sort of models can be very helpful for reasoning about resource utilization. How many clinicians do we need in a given location? Where should we place those clinics to best serve the population? And can be used, you notice the clinics are sizing according to their caseload at the moment. Yeah. So if more people are at a clinic at a given time, it will be larger. As people get served, and once they leave the clinic, it will shrink again. So these are this is an example of a hybrid model. Hybrid because we have a representation not just of the individuals, but each of the clinics. Clinic 1, 2, 3, 4 different clinics. And these numbers here provide information on the number of people served and the number of people who have balked for waiting times, who have left because they're taking too long to be served. Very readily done in today's technologies using a package like AnyLogic, and very fruitful for some of the insights it can give when you have a coupling between progression of conditions on the one hand and service delivery. And from the little amount I know and I'm learning in the infant and child health services, in the infant and child health area, it seems that service delivery is a very important shaper in potential health trajectories. So you can capture that with these sort of models in a way that would be more complex and more involved with a pure agent-based model. So anyway, bit of a glimpse of that. You can play around with it. This was this model called multi-clinic ABM process NC for North Carolina, and it's in.
What model is this? What kind of?
Oh, it's a hybrid. It's a hybrid, what's called hybrid agent-based and discrete event modeling. Oh, okay. The term discrete event modeling is a very poor name for it. I prefer the name process-centric modeling. It's centered around the care processes that are associated. Left to itself, the care process models give you some insight, but they're very constricted. In a realistic context in a hospital, say, you can create a care process model for about the emergency department, but once you start going beyond that, the rules become flexible enough and issues having to do with bed sharing that it's very hard to scale it alone. But coupled with agent-based modeling, it's very powerful, very powerful. Okay? So when you're dealing with workflows associated with case processing, with the gating processes to get someone under care, when you're dealing with multiple services and service interaction, these sort of models could be a real asset, I believe. Okay. So any questions about those before I dive into the next topic here, which is modeling as a learning tool for communities? Questions? Okay. So we're a bit behind, so I'm going to need to make up time. Fortunately, we can do so. By the way, one thing I'm not showing you is actual agent movement, mobility, like actually seeing them move back and forth. And I will try to upload a model where you can actually see them going back and forth more clearly. Okay, so modeling is a tool for teams and communities here.